Hello, let us take a look at nonlinear minimum mean square error estimator. So the problem in nonlinear mean square error estimation or nonlinear MSE estimator is that we assume that you have the joint density of two random variables. And then we have the observed value of one of them, and we don't know what values y takes on. So using the non-value, the knowledge of x, we want to know what is the best estimate of y. So we want to give an estimate for y, and we have the joint density of fxy of x and y. So we need a function or some relationship which can give us these best estimator. So the best estimator here, the criterion, how we choose this estimator, we want to find an estimator which is optimal in the sense of mean square error. So we want that the error between these is the estimator. Here we assume the condition that x is known to be value x, and this is the error y minus c. Y minus c is equal to the estimation error. So the error between the true value and the estimated value, and a squared of it, and this is the mean of the squared value. So we want to minimize this function in order to find the optimal value of c. So basically this expression is the value that these guys take on, which is y minus c to the power of 2 times the distribution. Here the distribution is that we know the value of x is equal to this one, and we have to write the distribution of y. So remember that y given x is equal to the joint distribution fx y of x and y, and then divided by the marginal distribution of fx of x. So you have to put this one in this expression. Do the integral and then calculate the derivative with respect to. So this is going to be an expression only in terms of c, and y here is a dummy variable, so y disappears. So this is a function of c and x. Now we can calculate the derivative of this function with respect to c, MSE, and then set it equal to 0 and then solve it. Once you solve it, so the derivative of this one is just going to be minus twice y minus c, and basically when you solve it, the optimal estimator is given by this integral. So remember that this conditional distribution is the ratio of the joint distribution divided by the distribution of only x. So basically this is this expression is the conditional mean of y given x equal x. So the best estimator of y is just the expected value of y given x. However, this function, this is a function of that, which is equal to integral of y varies from minus infinity to plus infinity of y fx y of x and y divided by fx of x, and then dy. So you see that this integral, the dummy variable y disappears and is a function of x, is a function of x, which is obtained using the joint distribution. This function in general is nonlinear. This is why we call these optimal estimator in the sense of mean square error as a nonlinear mean square estimator. So the optimal MSE estimator is the conditional expectation of y. So this is in general true and is a nonlinear function of x. The trouble with that is that in order to find these, you need to have to calculate this integral fx of y of x and y divided by fx of x dy over y. So you need a lot of knowledge about their joint distribution, which may not necessarily be available to you. Sometimes it's available, and because you don't know it, so estimating and finding these nonlinear function may not be practical if you don't have the joint distribution. But theoretically, this is very interesting, and it gives some guideline to more practical distribution. So interestingly, if you say that my estimator is a function of random variable x, and then you minimize this problem, you get the same estimator here. So this is another way to obtain it.